Hello everyone, welcome to Memoneet. I am Aprajita, your chemistry SME, and I welcome you all to another amazing session here with me. So first of all, I hope all of you are doing good and your preparation is going well. So I hope you people gave your Bhramastra part test too, and how did it go? I hope it was like really well. You people were able to solve the questions and you have watched the video solutions for it, right? In case you have not watched it yet, please go and watch. It is live on our YouTube channel. There you will get the video solution for each of the questions that were asked in Bhramastra part test 2. Okay, and even for part test 1 we have. And before starting with this session, I hope you are following up with the lectures and all the students have gone through all the 6 lectures which have been posted earlier, right? Now, for those who don't know what is this Bhramastra part test, so we are having this Bhramastra test series in which we are doing the tests one by one. So in your BPT-1, the chapter was some basic concepts of chemistry, and in BPT-2, the chapter was solutions, right? And in solutions chapter, like it is from class 12th, like we promised that the chapters will be from 11th and 12th simultaneously. Now you will be having your third part test. Now you still have 2 weeks for that, but it is on 16th of June. So what is the syllabus for that? So actually it's a cumulative test. Cumulative test means whatever has been covered till now will be asked in Bhramastra part test 3. Means the 2 chapters, some basic concepts of chemistry and solutions, they will be asked in your BPT 3. So, what is the benefit of that? Let me tell you. In case you were not able to cover some concepts of the chapter, or like you did only half of it or 75% of it, and you were not able to like score good marks, okay, so don't worry, we have got you covered. Now you can revise both these chapters once again, okay, like all the concepts and whatever is left with you, you can revise that again, and we will be having a test on those 2 chapters again, right? So now what we are here for today, we have already discussed the theoretical concepts for both the chapters. And let me tell you a specialty about both these chapters. Both these chapters have got mainly numericals. If you analyze your Brahmastra part test and even if you analyze the PYQs, so in that case students, I can say 75% of the questions are numericals from these 2 chapters, right? Because they belong to your physical chemistry portion. So what we are going to do today is we have already revised the concepts. In case you have not studied the concepts, go through my earlier videos. Okay, for BPT-1 and BPT-2, there I have got you covered all the concepts of these chapters, all the important concepts directly from the NCERTs. Okay, so today we will be discussing few numericals from this chapter. And why discussing those numericals? I'll be taking numericals from each of the topic, right? So what will happen if we discuss these numericals? Our concepts would be clear. So earlier we discussed the concepts. Now today I will tell you how to approach the question, how to solve a question, right? If it comes in the exam, how we are going to solve that, and what kind of questions are asked in the exam. So I have taken few questions from the Bhramastra part test only. Those students who have not given it might also get an idea about that. And in the next class, we'll be talking about the PYQs as well. Okay, the previous year questions that are very, very important for your NEET preparation. So let us start with the questions. Okay, so let me start with the first question now. So here is the first one, students. The question says that the number of moles of nitrogen molecules required to produce 50 moles of ammonia through Haber's process is. So can you tell me from which topic this question has been asked? This question has been asked from the concept of stoichiometry, right? We have discussed about stoichiometric calculations, like what we have studied is that whenever we are writing a balanced chemical equation for the reaction, we can find out the number of moles, we can find out the mass of the reactant products, we can find out the number of molecules. So all that comes under the stoichiometry. So here we are talking about the production of ammonia through Haber's process. So you know that nitrogen gas and hydrogen gas combines to form ammonia, right? And this is known as Haber's process at certain conditions of temperature and pressure using finely divided iron as the catalyst. So now I am going to balance this equation. Okay, so it's 2NH3 and 3H2. So this is the balanced chemical equation for this particular reaction. Now I want you to notice here the number of moles of reactants and products. Okay, so we'll be doing in detail, no issues. So I have 1 mole of nitrogen which is reacting with 3 moles of hydrogen, and what we are getting is we are getting 2 moles of ammonia, right? So we are getting here 2 moles of ammonia. So in this case, students, what we have got is the question asks that number of moles of nitrogen required to produce 50 moles of ammonia. So I need to relate the number of moles of nitrogen with ammonia. So clearly from the question we can say that 2 moles of ammonia is produced from how many moles of nitrogen? 1 mole, right? And this, from where I have got the idea? I have got the idea from the balanced chemical equation. So that is why writing the balanced chemical equation is really very important. Okay. So 2 moles of ammonia is produced from 1 mole of nitrogen. Okay. So it means how many moles are asked in the question? 50 moles. So I can clearly write for 50 moles. So 50 moles of ammonia will be produced from how much moles of nitrogen? So I can write 1 by 2 into 50. The basic unitary method will be applying. So it will be 25 moles, right? So yes, 25 is the option. It's option number 4. So answer for this question is option number 4. So what I want to tell you is this is a very easy and a very basic question, but we will be starting from basic questions only. Then we can do the high level questions as well. Alright, so this question was also asked in your BPT-1 and I hope most of you have got it right. So this is how we are going to do. So here it was asked the production of ammonia by Haber's process. They can give you any reaction. So you must be able to write the balanced equation for those reactions and then you will be able to do the questions. Okay, so we will be moving ahead now to the next question. So here we go. Okay students, so the next question is here. This is also related to your stoichiometry, but a little bit different and a unique question. That's why I have taken it for you. So it says mass of calcium carbonate required to react with 400 ml of 1.5 molar HCl solution is. Okay, so here calcium carbonate is reacting with HCl. All right. So this is going to be the reaction. Again, first you have to write the complete reaction equation. All right. So you know when metal carbonates react with acids, what do you get? You will get a salt, calcium chloride plus carbon dioxide and water. And now I need to balance this equation. So I think only 2 HCl will be required here because only hydrogen and chlorine were not equal. Now count the number of other atoms. Yes, this is equal. So this is the balanced equation. Okay. So now you can see from this equation 2 moles of HCl react with, or you can say react completely with 1 mole of calcium carbonate. So here we are talking about mass. So what is the mass, molar mass of calcium carbonate that we can write? So molar mass of calcium carbonate is calcium is 40 plus carbon is 12 plus 3 into 16 for oxygen. Okay, so 40 plus 12 plus 48. So it will be 100 gram per mole. So it means I can say that 2 moles of HCl will react with 100 grams of calcium carbonate. Now I need to find out ki how much calcium carbonate is required for 400 ml of 1.5 molar HCl solution. Now M means molar, molarity. So you know students, from here I need to find out how many number of moles of HCl are there. Okay, so the formula for molarity is number of moles of solute, okay, upon volume of solution in liters multiplied by 1000. Okay. Or you can say if it is in milliliter, so then I have to multiply it with 1000 milliliter. Okay, if it is in liter, then it's okay. So volume is in milliliter. So from here, molarity is given 1.5. Number of moles I can write as small n. Volume of the solution is 400 and it is 1000. Okay. So this is going to be the formula. From here you can find out the value of number of moles. So from here number of moles will be 1.5 into 400 upon 1000. Okay. So please solve it. How much it will come? So you can solve it on your own. Okay. So from here you will get 0.6 moles HCl. Okay, so it means in the question it was given 1.5 molar HCl, 400 ml of 1.5 molar HCl will have 0.6 moles of HCl. Now from the question here, 2 moles of HCl react with 100 grams of calcium carbonate, right? So please write 2 moles HCl react with 100 grams of calcium carbonate. So 1 mole will react with how much? 100 by 2, and 0.6 mole will react with how much? 100 by 2 into 0.6. So it will be 0.3, and 0.3 into 100 is 30 grams. So means this much HCl, this much calcium carbonate will be required. Okay. So the answer is going to be 30 grams, which is your option number 1. Alright. So this much mass is required in this case. I hope everyone is clear. So let me recall it. Firstly, we have written the balanced equation in this case, and here we have seen that 2 moles HCl react with 1 mole of calcium carbonate, means 100 grams of calcium carbonate. So from the given molarity and volume, I have found out the number of moles, and using that we have found out the required value of calcium carbonate. So I hope this much is clear, students. Okay, students, next question again from stoichiometry, but again another different type of question. Volume of CO2 obtained at STP by burning 32 grams of methane with 64 grams of oxygen is. So firstly, we are burning methane. Let's write the equation. CH4 plus oxygen gives, whenever hydrocarbon burns, it gives CO2 and H2O. Now you need to balance this equation. So I'm writing this balanced equation. You can clearly see the number of hydrogen atoms are 4, oxygen is also 4, and carbon is 1. So this is the balanced equation. Now what we can get from this equation, that 1 mole of methane reacts with 2 moles of oxygen to form 1 mole of carbon dioxide. Now in terms of mass, let's write. So 1 mole of methane is 16 grams, right? 16 grams of methane, because it's 12 plus 4 into 1 for methane, and for oxygen, so it's 32. 2 into 16 na 32, and since there are 2 moles, so 2 into 16 means 32 grams of oxygen. It will give you how much? 44 grams of carbon dioxide. Okay, 44 grams of carbon dioxide, and rest water plus 36 grams of water. So that's what is not required. So we are not writing it. Okay, 2 into 16, 32, and 32 is for 1 mole na. So it will be 2 moles. So please write it here. 32 and 2 into 32, that is 64. Means 16 grams of methane is going to react with 64 grams of oxygen to form 44 grams of carbon dioxide. Okay, so that's the case here. Please note. So students, here in this case, what is the amount of methane given? So here 32 grams of methane is reacting with 64 grams of oxygen. So you know that 1 mole of any substance will have 22.4 liters. 1 mole of any gas will have 22.4 liters at STP. Okay. So now here you can see 32 grams of methane means 2 moles of methane. Okay. 2 moles of methane. And see, from the question, 16 grams of methane reacts with 32 grams of 64 grams of oxygen, right? So students, here it's reacting with 64 grams of oxygen, right? But in the question, 32 grams of methane is there. So if 16 grams reacts with 64 grams of oxygen, so 32 grams of methane requires 2 into 64 means 128 grams of oxygen. But we don't have 128 grams of oxygen. We have only 64 grams, means less than what amount is required. So do you remember what will be the case? So here oxygen will be acting as the limiting reagent. Limiting reagent is the one that limits the product, because 32 ग्राम of methane को react होने के लिए 128 grams oxygen चाहिए, but in the reaction we have only 64 grams, तो सारा 32 grams methane react नहीं होगा, only 16 grams react होगा 64 के साथ, बाकी जो 16 grams है वो unreacted रह जाएगा. So from here you can see कि it is the limiting reagent, so it will tell us the amount of product. So 64 grams of oxygen, from here you can see it is giving you 1 mole of carbon dioxide, which is 22.4 liter. So in this case also you will get 22.4 liters of CO2. So the answer is option 3. Okay, so this is how you are going to solve it. Alright students, so that will be the solution. Here यहाँ पर हमने stoichiometry का concept लगाया, plus we have added the concept of limiting reagent as well. Alright, so moving on to the next question. So students, here is your question. Please see. Total number of electrons present in 27 grams of Al3 plus ions is. So now you have to find out the number of electrons. So which concept you will be applying? We will be applying the mole concept here. Okay. And in the mole concept, students, first of all, I have told you we will be finding out the number of moles. So do you remember what is the formula for number of moles? Number of moles is equal to given mass divided by the molar mass. So in this case we are talking about aluminium ions, so we will be taking the mass of aluminium atom only, means the atomic mass, which is 27 grams. Okay, gram atomic mass is 27 grams. So number of moles is given mass is 27 and molar mass is also 27, so it's 1 mole. Okay, now we need to find out the number of electrons. So please see that number of electrons in one aluminium ion. Okay, so one aluminium ion is, so aluminium has 13 electrons. You all know, right? Aluminium's atomic number is 13, so it has 13 electrons, but it is 3 positive, means 3 electrons it has lost. So one aluminium 3 plus ion will have 10 electrons. Okay, and 1 mole of aluminium ions will have 1 mole aluminium ions. 1 mole aluminium ions means Avogadro's number of aluminium ions, which is 6.022 into 10 to the power 23 aluminium ions. So students, this much aluminium ions will be having how much? 10 into 6.022 into 10 to the power 23 electrons. Okay, एक आयन में 10 इलेक्ट्रॉन्स है, तो Na आयन्स में कितने होंगे? 10 into Na. तो हम यहाँ पर Na लिख सकते हैं. So 10 times Na electrons would be there. So answer is going to be option number 2. Right? So this was an easy question. It's just that सिर्फ the knowledge of the mole concept was required in this case. Okay. So I think this one is also clear. Next up. So students, the next question is based on empirical formula. You know, this is also one of the important topic of this chapter. So it says a compound X contains 32% of A, 20% of B and remaining percentage of C. Then the empirical formula of X is the atomic mass is given. Okay. So first of all, I have told you how to write the empirical formula. First of all, write the elements that are given here. What is their percentage? Okay, so if percentage is given now, so 32% of A means if there is 100 gram of the compound, then there is 32 grams A in it, 20 grams B, and remaining, how much is remaining? 100 minus 32 plus 20, which is 100 minus 52, so 48 grams of C. So please write the amount of A, B, C, which is 32, 20 and 48. Now what is the atomic masses or the molar masses are given to you, which is 64, 40 and 32. Alright. Now you will find out the number of moles. Number of moles means given mass upon molar mass. So 32 upon 64, which is 1 by 2, means 0.5. 20 upon 40 it would be, na? Given mass is 20 and the mass is 40. So 20 upon 40, it is going to be 0.5 again. Then 48 upon 32. So it will come out to be 12 threes are, 12 fours are, and 16 threes are and 16 twos are. Okay, so 3 by 2 means 1.5. Okay, so now you have got the number of moles. Now you will find the simplest ratio. So do you remember how to find out the simplest ratio? Divide these values that we have come with the smallest value. So which is the smallest value here? 0.5. So 0.5 upon 0.5 is 1. Here 0.5 upon 0.5, again it's 1. 1.5 upon 0.5, it would be 3. So you have got the simplest ratio for ABC. So A1, B1 and C3. So see, we have got the empirical formula, that is ABC3. Alright, so this is so simple. This is how we are going to find out the empirical formula if we know the percentage composition of all the elements in the compound. Okay. So I hope students you are able to get how to approach these questions and how to solve these questions. The next one is related to molarity and molality. So this has come in this chapter, but yeah, it can be a part of solutions as well. Okay. So it says the density of 1 molar solution of a compound X is 1.25 gram per ml. Correct option for molalities. Okay. So molarity of the solution is given. 1 m means it is 1 molar. Okay, so what does 1 molar solution mean, students? 1 molar solution means that 1 mole of solute is dissolved in 1 liter of solution, right? That is what molarity is, na, number of moles of solute in per liter of solution. So if it's 1 molar, so means 1 mole of solute is there. Alright, so what we can say here is that 1 liter means 1000 ml. Okay, so from here the volume of solution is 1000 ml and the density is given, right? Density is given 1.25 gram per ml. So if volume is given, density is given, can you find out the mass of solution? Yes, we can find out the mass of solution, which will be volume into density. So 1000 into 1.25, so it will be 1250 grams, right? So this is the mass of the solution you have. Now why I have calculated the mass? Because molality is number of moles of solute in per kg of solvent. So I need to find out the mass of solvent. So for that I need to know what is the mass of solute. So how much solute is dissolved in this solution? You can see 1 mole. And what is the molar mass of solute? It is given 85 grams. So if 1 mole is dissolved, so it means the mass of solute is 85 grams only. Alright. So from here you can find out the mass of solvent. So it would be 1250 minus 85 means we have subtracted the mass of solute in this case. So students, from here it will be come out to be 1165 grams, right? So 1250 minus 85, it's 1165 grams. That is the mass of solvent. Now you can clearly find out the molality. Molality is the number of moles of solute, which is 1 mole dissolved per kg of the solvent, right? So it's 1165, it's in grams, so into 1000. All right, so you will be solving it. It will come out to be 0.858 molar. Okay, 0.858 molar. So it's option number 4. Alright, so that is going to be the answer. This is how from the molarity we have calculated the molality of the solution. Okay. So students, this question was important because the molarity and molality concept has been asked, or it is present in the chapter solutions as well. Okay, so from here firstly molarity was given. From there I calculated the number of moles as well as the volume. So density was given. From there we calculated the mass of the solution. So when we calculated the mass, we need to find out the mass of solvent and then we will calculate the molality. Okay, because the molality is number of moles of solute and divided by mass of solvent in kilograms. All right. So here the mass was in grams now, so that's why I divided it with 1000 and it went in the numerator. Now next question, again a very interesting one from mole concept. If 10 to the power 20 molecules of H2O are removed from 18 milligrams of water, then how many moles of water are left? So earlier you are having 18 milligrams of water. इसमें से हमने 10 to the power 20 molecules जो हैं वो remove कर दिए, right? Water के. तो कितने moles हमारे पास बचे, राइट? हाउ मेनी मोल्स ऑफ वाटर आर लेफ्ट? सो फ्रॉम दैट फर्स्टली अगर हम दोनों के नंबर ऑफ मोल्स निकाल लें, इफ आई फाइंड आउट द नंबर ऑफ मोल्स ऑफ 18 मिलीग्राम ऑफ वाटर एंड नंबर ऑफ मोल्स ऑफ 10 to the power 22 molecules and then उनको subtract कर दे, we will get right कि how many moles are left. Simple. So you know that 18 milligrams of water means 18 upon 1000 means 0.018 grams of water, right? So now find out the number of moles. So number of moles in this case is the given mass, which is your 0.018 divided by the molar mass, which is 18, right? So from here I can get the number of moles. So the number of moles be 0.001 mole. Okay, now you know that 1 mole of any substance has how many particles? 6.022 into 10 to the power 23 particles, right? So if I want to find out that number of moles in 10 to the power 20 molecules of water, then what it would be, class? It is going to be 10 to the power 20 and हम इसको divide करेंगे with the Avogadro's number. Okay, 10 to the power 23. So इसको solve करना है, it will come out to be 0.00016 mole. So when you will solve it, now you have got the number of moles. So इतने मोल्स हमारे पास ऑलरेडी थे 18 मिलीग्राम्स में एंड इतने मोल्स हमने रिमूव कर दिए. सो द नंबर ऑफ मोल्स दैट आर लेफ्ट, सो कितने मोल्स बचे हैं? दैट इज 0.001 माइनस 0.00016. ओके, सो लेट्स सॉल्व इट. इट्स 0.00083. सो इसको आप लिख सकते हैं 4 प्लेस डेसिमल मूव करेंगे 8.3 इंटू 10 टू द पावर -4, क्योंकि सिग्निफिकेंट फिगर्स में हमें आंसर लिखना होता है. सो दिस मच मोल ऑफ water would be left. Okay students, so answer is going to be option number 2. I hope that much is clear. So students, this is how you are going to solve the questions of number of moles, right? Now one last question, this is very easy. What is the number of significant figures in 0.3015 into 10 to the power 3? So students, okay, you know that the zeros that are on the left hand side of the number, it is not significant, and 10 to the power 3 also it will not count. And after decimal, all the zeros, or like here the numbers are 3015, right? And this 0 is between the two non-zero digits, so it is going to be significant. So here we can say that the number of significant figures is going to be 4 in this case, which is your option 3. So students, this is how we are going to solve the questions. So today we have taken some of the questions from the BPT-1, like the important numericals I have taken from each of the topic, from some basic concepts of chemistry. Okay, we will be also discussing the PYQs. Okay, the previous year questions we will discuss, so that you will get an idea of what kind of questions are asked in the exam, although they are related to these questions only that we have given you in the test series. All right, so but we will have another session on the PYQs and I'll tell you some interesting things from the PYQs as well. Okay, so stay tuned for that. Till then, solve these questions and revise the chapter once again if you are left with any concepts. So now it's the time you can revise it. So we have planned the test in such a way so that you can get enough time for every chapter. So both the chapters are going to come in your BPT-3. So revise them well so that your concepts get revised again and again. And in case you have any doubts, you can ask us in the comment box, or you can ask me through the Telegram channel. Link for the Telegram channel is in the description. Please join that. Okay. So thank you so much, students. We'll meet in the next session. Until then, bye bye. Thank you.